Okay, so we talked about this equation. It's C equals to F lambda. If you guys don't remember, C is the speed of light and it's a constant. The speed of light does not ever change. Speed of light and then frequency of the light, and this is your wavelength. Wavelength is in meters. This guy is in hertz. And speed of light is in meter per second. It's the speed, right? Speed or velocity of light. And then we also talked about blackbody radiation. We've learned this in chapter 14 before. I believe this will not be on the exam, but baca je lah, baca je in your module book. It's there. It's just like a summary of the blackbody radiation. I'm not going to go through it too much. And then from chapter 14 as well, we have the Stefan's law, P equals to sigma E A T to the power of 4. You should know how to use this equation from chapter 14 lah, okay? And then the blackbody radiation shows, we know that they did an experiment and they measured the power density emitted by the object, and it shows that it follows a certain radiation curve. So that radiation curve is given by this, I believe. Okay, so not that important in my opinion. Okay, next one. Okay, so classical theory did not match the experimental data. At long wavelengths, the match is good. At short wavelengths, the classical theory predicted infinite energy. So here, kalau kita tengok, if we look at this diagram, the classical theory predicts that our intensity of light goes like this. So the shorter your wavelength, the higher your intensity, or basically the intensity goes to infinity. So which is wrong? So classical theory ni dia bagus untuk predict at longer wavelengths. However, at shorter wavelengths, the classical theory does not hold, which means that it's not complete. The theory is not complete. What does it mean by not complete? So as you all know, Einstein developed a lot of theories and macam-macam lah. Planck pun developed a theory. So every time a scientist comes out with a theory, they will try to like cabar teori-teori yang sebelum. Kalau tak cabar pun, diorang akan guna part of the theories that was discovered before. As you all know, science ni is like an evolving knowledge. When we know about something lagi, macam nak cakap, when we have a better idea of something, when we have extra knowledge, when we improve our knowledge, kita akan guna that improved knowledge. So this is how humans progress. My internet is unstable. I hope tak terputus. Okay. So this is how we progress lah basically. So contohnya, saya buat eksperimen on lasers. That's what I do. So I come up with a theory and I say that okay, lasers yang macam ni sebenarnya tak boleh tembak ke langit. Contoh, it's not like that. So lasers tak boleh tembak ke langit. That's my theory. So what I'm doing is that saya cabar orang yang pernah cakap laser ni boleh sampai ke langit. So when I cabar orang lain ni, I have to come up with the results or the proof or the experiment data, and I have to show them that this is what I did, this is my experiment, and this is the results. So my results is verified, which means that orang dulu-dulu yang punya teori tu tak valid dah. So they have to use my theory. So this is how science progress. Every time we get experimental data, we use it. Every time we get new data, we get new information, we use it. And this is how science evolves. So we get better lah each day. Okay, so this is why scientists are very important. So classical theory fails to predict what happens to the intensity of light at shorter wavelengths. So this is called the ultraviolet catastrophe. So nanti akan datang lagi lah another theory to help the classical theory explain this. Okay. Oh my god, tak boleh nak baca ni. Okay, so classical theory could not explain blackbody radiation, photoelectric effect, Compton scattering, tak payah, spectral lines. Basically classical theory ni banyak gaps dia. It's a good theory, but it did not explain a lot of stuff. So the quantum theory approach, waves can exhibit particle-like characteristics and particles exhibit wave-like characteristics. So basically quantum theory ni cakap wave this is energy. Energy can exhibit particle-like or wave-like characteristics. Okay, so this is the quantum theory approach. Quantum theory approach versus classical theory approach. Classical theory banyak gap, banyak benda yang dia tak boleh explain. So quantum theory was proposed. Okay, so tu je. And then we talked about the equation E equals to HF. Light energy is quantized. This was proposed by Max Planck. Max Planck. So Max Planck ni, H is Planck's constant, E is quantized. Dia cakap, Max Planck cakap, energy is quantized. Quantized meaning it has a certain value. Value dia tak boleh sesuka hati. And dia macam dia macam ni lah rupa dia. Tak nak cakap macam mana. So if you have, kita ada gambar dia, tak silap. Okay, so this is light, flashlight, and this is your light. So energy is quantized, meaning to say that they have like certain value of energy to them. Certain value of energy to them. Kiranya dia tak boleh lah macam sesuka hati nak energy, tak boleh nak random value, tak boleh. Kena ada certain value, and that value relates back to the frequency. So here, as you can see here, in each of this particle ataupun each of this bulat ni ada wave. So for each particle of energy, there is a frequency or there is a wave related to it. Okay, so this is E equals to HF or HC over lambda. Okay, and then to Planck, and then we talked about Louis de Broglie punya theory. They propose that wave particle tu betul, but they also have mass and velocity or momentum lah basically. Momentum. This is mv equals to momentum. So de Broglie's wavelength, dalam equation dia ada momentum mv. So dia still pakai Planck tapi dia improve Planck punya equation. So lambda equals to h over mv. Okay. And because of wave particle duality, we can see that it behaves like a wave. Diffraction only happens kalau they behave like a wave. So diffraction only happens when something is a wave. So here we can see that, yes, it behaves like a wave. It also behaves like a particle at the same time. Okay, so dia particle and both wave. It's a little bit confusing. Tapi memang macam tu. Saya pun confused waktu saya mula-mula belajar. Okay, so the development of quantum theory, Planck made an assumption that energy is made of individual units or quanta, the bulat-bulat thing. And then Albert Einstein theorized that not just energy, but the radiation itself was quantized in the same manner. Energy ni sebenarnya radiation lah, it's the same thing. Okay, so Louis de Broglie proposed that there is no fundamental difference in the behavior of energy and matter. This theory became as the principle of wave particle duality. So we have E equals to HF, we have E equals to HF equals to H over mv. Okay, and then in 1927, Werner Heisenberg proposed that it is impossible to simultaneously measure the position and momentum of a subatomic particle. This theory became an uncertainty principle. Okay, so what you can do for this part is you can just read the module. I believe it's better summarized here compared to the slides. Korang baca je. Will there be a question about this? Uncertainty principle tak kot. But this one and photoelectric effect most likely. Okay. Sebab yang ni dia tak explain dalam module. Even Blackbody Radiation pun dia tak explain betul-betul dalam modul sebab kita dah cover dalam chapter 14. So please focus on the things that they ask you to calculate in the module. And also benda yang diorang suruh explain. Okay, kita dah go over this one. Remember, if you want to change energy into EV, divide by E or times it with, I forgot apa yang kita buat hari tu. Kita search for how to convert energy to EV, right? So there was a constant involved. You can either divide it by E, which is what they are doing here, or times it with the constant. I don't remember what it is. Okay, nanti korang cari balik. Okay, kita dah buat semua ni. Okay, so now we go into the photoelectric effect. Okay, so for this subtopic, you need to explain what the photoelectric effect is. So you need to explain. Describe the photoelectric effect, experiments and state the results. Describe the Einstein explanation of photoelectric effect. Use the energy equation of the photoelectric effect. I think you should focus this for your exam. Okay, so photoelectric effect, when light is incident on a certain metallic surface, electrons are emitted from the surface. This is called the photoelectric effect. So what happens here, let's look at this diagram. Yeah, saya besarkan. Okay, so you have light rays here. Light rays is photons. It's called photons. Photons that is incident to a metallic surface. So this guy is your metallic surface. Doesn't matter what type of metallic surface as long as it is metallic. So when light is incident to a metallic surface, it immediately emits electron. So this is electron emission. So this is called the photoelectric effect. So you give it photon, what you get is something electron. You get the E. So this is photoelectric effect. The emitted electrons are called photoelectrons. Okay, you can call it electrons or photoelectrons. The effect was first discovered by Hertz. The successful explanation was based on Planck's hypothesis. Apa kat sini tak membantu sangat kita. Okay. Tak sukalah slide untuk chapter ni. It's not nice. The photoelectric effect refers to the emission of electrons from a metallic surface, usually caused by incident light. The incident light is absorbed by electrons, thus giving them sufficient energy to break from the surface, metallic surface. So what happens here is when we have photons that is incident, photon ni energy kan? Photon is a quantized energy. Walaupun dia light, dia quantized energy. Maksudnya bila dia incident, dia akan diabsorb oleh the electrons in the metallic surface. So bila dia absorb, dia vibrate and then if the energy is sufficient, baru dia boleh keluar. Baru dia ada kinetic energy untuk berlepas. Okay, so it needs sufficient energy. If the photon that I give to this metallic surface is low, the photoelectric effect cannot happen. So ada the threshold, ada a certain value yang dia kena capai untuk photoelectric effect to happen. Jadi kita akan tengok equation untuk describe this. Okay, so photoelectric effect experiment. So this is the experimental setup. Diorang nak kaji betul-betul macam mana benda ni berlaku. So this is the setup that they had. So we have our incident light here. This is how it looks like. And then this is the metallic surface that they use, and this is when the photon electrons emit, dia akan diabsorb oleh the collector. Ya, tulis kat sini, collector. This is called the collector. Sekejap, saya tengok ada yang lagi dia tak bagi tu kat sini pula. Okay, never mind. Nanti kita tengok balik diagram sebelah tu. Okay, so incident light, and then when electrons emit, it is collected by the collector and then it goes through here and benda ni akan measure lah, the voltage is measured and also the current is measured. This is the setup lah in general. So let's look at this one. This one I think is better. When the light strikes metal target E, okay, so this is our metal target E. Okay, so this is light, metal target E. The collector C is maintained at a potential difference. Collector C is maintained at a potential difference. So dia connected to this voltage supply, right? So it has a certain voltage to it, maintained at a potential difference. Potential difference is also voltage by the variable power supply with respect to E. So E pun connected, right? But E is connected to the negative side. Collector is connected to the positive side. The photoelectrons are collected at the collector C. So when we shine light to the metallic surface, the electrons emitted go to the collector. The emitter A measures the photoelectric current. The emitter A, it measures the photoelectric current. Sorry, voltage ni dia measure potential difference between E and C. Does not measure the photoelectric effect. The voltage here It measures the potential difference between E and C. Sebab C dekat positif, E dekat negatif. So V ni is the potential difference between the both of them. When the electrons or the photoelectrons is collected by the collector, you will get a reading at the emitter. So this is how the photoelectric effect experiment is done. Okay, so now let's see if we have the results in this slide. Sekejap kenapa tak sama macam buku? Okay, tak apalah. Okay, so electrons are emitted from the surface almost instantaneously. Kalau kita tengok kat sini, when the light is shown, when the light is shine on the metallic surface, dia tak ada tunggu 2-3 saat ke, tak ada, dia terus emit, kita terus akan dapat reading dekat emitter. So when I put the light at the metallic surface, I immediately get a reading at the emitter. So it happens instantaneously, split second, less than a second. Okay, very fast. Okay, so wave theory fails to explain this experimental observation. Okay, kenapa wave theory fails to explain this experimental observation? Because even at low intensity, kita akan dapat photoelectric effect. But in reality, when we look at the diagram that we saw earlier, saya tunjuk balik. Dia cakap classical theory ni cakap kalau dekat low intensity kita tak boleh dapat this emission, tak boleh dapat wavelength, tak boleh dapat frequency lah basically. But what we saw here is even at low intensity kita boleh dapat. Tapi low intensity tu kena ada a certain, dia kena match dengan threshold of the metallic surface. Nanti kita akan cakap pasal tu. Okay, so if light is in the form of a wave, it needs some time to accumulate enough energy to release the electron. But what we saw was that when we shine the light, photoelectrons are immediately emitted. Okay, itu tak menggambarkan property of a wave. Okay, contohnya, you need to fill the bowl continuously to remove the ping pong ball. Okay, so if light is in the form of a wave, it needs some time to accumulate enough energy to release the electron. Maksudnya, it does not happen instantaneously. Okay, kalau betul benda ni acts as a wave sahaja, then it would be like this. You have to fill in water in a bowl continuously untuk keluarkan bola. Ni photoelectric lah. Ni photoelectrons, sorry. So if they behave like a wave, you would have to provide, you would have to continuously supply energy to get the photoelectrons to emit. Okay, so this is what wave theory cakap. Tapi what we saw was, saya letak je light terus keluar. Okay, so kalau kita buat macam tu, it behaves like this. Letak je light, terus keluar. So it behaves like shoot with a tennis ball to remove the ping pong ball. So this is what we saw. So this is our light, kita tembak tennis ball, terus keluar photoelectrons. This is what we saw because it happens instantaneously. Tembak tennis ball, terus keluar. Kalau wave theory, kena masukkan air lama baru boleh keluarkan photoelektron sebab dia kena capai mangkuk level yang tinggi, kena capai paras air yang tinggi kan, baru dia boleh keluar. Ni wave theory. Tapi apa yang kita nampak is this is what we saw. Emit, kita letak light je, terus photoelectrons emit. This is what we saw. Okay. Okay, so current increases with intensity, but reaches a saturation level for a large applied voltage. This observation agrees with wave theory. Okay, so wave theory cakap kita kena anggap macam kita isi air kan. So bila kita isi air, kalau bola ada 5 je dalam ni, kalau bola ada 5 je, after paras air yang tertentu, bola tu dah tak ada dah lah. Bola tu semua dah keluar. So ada 5 bola yang emitted. So what we are left is nothing. We don't have any more balls to keluarkan. So this is wave theory. So wave theory cakap, so when current increases with intensity, but reaches a saturation level for large applied voltage. So this is saturation. This is called saturation. Kat sini bila kita letak air, bola keluar. Tapi bila saya letak air continuously, bola dah tak keluar sebab bola dah habis. So this is when saturation happens. Bola dah tak ada. Okay, so wave theory boleh apply dekat diagram ni. Increase intensity means increase in energy has increased current. Okay, so tu je nak cakap wave theory, cakap benda ni, diagram ni follow wave theory. Okay, I know it's a little bit confusing. So current increases with intensity, reaches a saturation level for large applied voltage. This observation can be explained both by wave theory and particle theory. So dia cakap even dekat high intensity, dia nak cakap kat sini kalau kita tembak banyak-banyak tennis ball pun, tapi kalau bola dah habis, dia habis jugalah kan, sama jugalah. Even with high intensity, we reach a saturation, no more balls. Okay, so wave theory and particle theory dua-dua boleh explain benda ni lah. So low intensity can be explained by wave theory, high intensity explained by the particle theory. Apa tu particle theory? Particle theory is the tennis ball. And this is the wave theory, air. Okay, isi air lama-lama baru keluar. Tennis ball, tembak terus keluar. That's the difference. Okay, I hope that's okay for everyone. Please cerita dengan berhemah sikit lah kalau diorang suruh explain. Jangan cakap tembak bola keluar. Jangan cakap macam tu. Tulis elok-elok lah. Saya cerita macam tu supaya korang faham. Okay, I think in the module you have it. Okay, so there is current flow even with negative applied voltage. No current flows for voltages less than or equal to minus Vs. Okay. Bear with me first. Dia nak cakap pasal statement ni dulu, nanti kita akan cakap pasal equation dia. No current flows for voltages less than or equal to the V stopping. Sekejap nak muntah pula. Okay, for the stopping potential. No current flows for voltages less than or equal to the stopping potential. Okay, stopping potential ni penting Stopping potential ni is your threshold. Nanti kita akan cakap lagi pasal ni. So stopping potential is independent of the radiation intensity. The stopping potential measures the maximum kinetic energy of the photoelectron. Okay. Sekejap, abaikan dulu yang pasal stopping ni. Sekejap. Okay, so now we have a new equation compared to E equals to HC, E equals to, HF, H over MV, HC over, lambda kan? Tak ingat lagi satu tu. Okay, so now we have our new equation, K equals to EV. So electron, stopping potential. I know this subtopic is like membosankan sikit, tapi bear with me. Kita belum sampai part calculation lagi. Stopping potential. Okay, so this is maximum kinetic energy. Kat sini untuk chapter ni kita pakai K max. It's not KE KE is kinetic energy. It's kinetic energy but it's maximum kinetic energy. Untuk chapter ni kita pakai K. Jangan letak KE Kalau orang suruh tulis equation, use K max. Okay. So what is stopping potential? The stopping potential is independent. The stopping potential measures blah. Okay. Wave theory. Sudahlah cakap pasal wave theory ni. Let's talk about the equation faster. Okay. Light is made of tiny packets of light called photon. Okay, we know this. Photon's energy is given by E equals to HF, Planck's theory. Each photon gives its energy to an electron in the metal by collision. Each photon gives its energy to an electron in the metal by collision. Bila kita emit light, dia kasih energy to the electrons by collision. Macam tennis ball tadi lah. Tennis ball tembak, dia keluar. Tembak, dia keluar. So it's like collision. Okay, so the electron ejected from the surface if the photon energy is greater than its binding energy. Okay, this is important. The electron ejected from the surface if the photon energy is greater than its binding energy. This is called the threshold. Sorry, bukan stopping potential tadi ya. This is the threshold. It's called binding energy. So kat sini nak kata the binding energy, contohnya binding energy of these photoelectrons is 2 eV. Kalau saya letak light, saya kasih light 1.5 eV, maksudnya light saya tak cukup untuk overcome the binding energy. When my light is 2 eV, then this is the binding energy, right? So if it is equal or greater to the binding energy, baru photoelectron ni emitted. Okay, so the energy received by the electron is used up to overcome its binding energy, and any extra energy is shown as kinetic energy. So remember, E equals to HF. This is what we know so far. So this is the total energy. E equals to HF equals to K max plus W. What is W? W is the binding energy or the work function. It has two names. So kita akan guna these names interchangeably lah. So K max plus W. So W is the binding energy. This is the minimum that the E has to be in order for photoelectrons to be emitted. So this equation is for your photoelectric effect. Okay, photoelectric effect. This is very important equation. Kena ingat. Ni memang confirm. Confirm masuk. Okay. So this effect is instantaneous since there is a one-to-one interaction between the photon and electron. Okay, we know this already. The photon energy the photon energy, light, is used to overcome the work function, binding energy of the electron and the extra energy as kinetic energy. So nak kata kat sini, kalau saya punya light ni is 5 eV, binding energy saya of the electrons in the metallic surface is 2 eV, right? So I have 5. This is the total energy that I'm giving the metallic surface. So to overcome the binding energy, I need a minimum of 2 eV, right? 2 eV. So what happens to the rest of the energy? It becomes K max. It becomes a kinetic energy. Okay, it becomes the kinetic energy of the photoelectron. So this becomes 3 eV. Okay, both sides need to be equal because energy cannot be created or destroyed. Right. So this is the KE. I mean the Kmax, sorry. E equals to 1/2 mv squared. Ni yang lebih-lebih. Tahu, kalau tak lebih, tak ada. Right. So the effect is not observed below a certain threshold frequency. Since the photon energy must be greater than or equal to the work function. So kita tahu E total is equal to HF. So if the frequency is too low, then your E is going to be too low, then it might be less than the work function. Untuk photoelectric effect to happen, it must be greater or equal to the work function. HF must be greater or equal to the work function or the binding energy. So the minimum energy is equivalent to the light energy with threshold frequency. So this thing can be plotted. So HF naught equals to W. Yeah, HF naught equals to W. Okay. Sekejap, saya cuba explain benda ni betul-betul. Jauh lagi tak? What time is it? Okay, we have time. Okay, so let's say, bukan let's say lah, F naught ni is the minimum frequency or the lowest frequency that my light has to be in order to overcome the binding energy. Okay, so for instance, let's say saya punya my work function or my binding energy is apa? Let's use 2 eV lah. Okay, so this is my work function or my binding energy. So my energy, my light energy, my photon energy must be greater than 2 eV. And we know that E equals to HF. Untuk overcome the binding energy, my E has to be greater or equal to 2 eV lah. Okay, so 2 eV. Okay, how do I convert eV to, I should have just used joules. Let's use joules. Let's use 1000 joule. Okay, energy is joules. Okay, so H is apa? H is 6.626 times 10 to the minus 34 joules second. Joules second. Oh, betul lah. Okay. So this is Planck's constant. Okay. And then frequency not. Tak tahu frequency not tu apa. And this is the work function or the binding energy, minimum energy to overcome the binding energy untuk photoelectron untuk emit lah. So this is the situation. So I want to know what is the minimum frequency that that the light has to have for photoelectrons to be emitted. So 1000 divided by 6.626 times 10 to the minus 34. So the minimum frequency that my light should have is 150.92 hertz. This is the minimum. Okay, so this is when my W is 1000 joule. What happens if my binding energy is greater? What happens when my binding energy is greater? So let's try again. So second situation, W equals to 2000 joules. Sekarang ni kita nak cakap, I need to have 2000 joules untuk photoelectrons to be emitted. This is the minimum energy. So again, using this, so now it's 2000. So now my F naught becomes 2000 divided by 6.626 times 10 to the minus 34. So my frequency, the minimum frequency, betul ke saya buat ni? Sekejap 2000. Kalau saya salah kira tolong cakap divided by 6.626 times 10 to the minus 34. 3 times 10 to 36. Saya punya jawapan ni salah lah. So F naught yang kedua is 3 times 10 to the 36 hertz. Sekejap kira balik tadi. 1000 divided by 6.626 times 10 to the minus 34. Ni mesti semua tengah mengantuk gila ni. It's 1.5 times 10 to the 36. Okay. So here, mula-mula kalau kita punya binding energy is 1000, we saw that the frequency, the minimum frequency should be 1.5. When my binding energy is 2000 joule, my minimum frequency should be 3 times 10 to the 36 hertz. So the frequency ni diberubah ikut the binding energy. So here, let's say, what I'm trying to say here is that the frequency, the minimum frequency depends on your work function ataupun binding energy. So here, if we say that our work function is 1000, our F naught should be 1.5 times 10 to the 36 hertz. So this is when F naught, this is F naught, and this is KE. When my energy is E equals to HF naught, it means that it only satisfies W. KE maksudnya kosong. I hope I'm making sense here. So if my total energy is HF naught, it only satisfies the binding energy. kan kita cakap kinetic energy of the photoelectron is only apa-apa yang lebih. Kalau kita ada 5 eV, this our work function is 2 eV, kita ada 3 eV. Tapi kalau kita punya energy cukup-cukup je untuk binding energy which is 2 eV, our work function is also 2 eV, then our KE is 0. So this is what happened. It become 0. So F naught always dekat 0 is what I'm trying to say here. F naught always at 0, 0 KE. So when I increase the frequency, boleh, when I increase the frequency, I will have extras to be used as my KE. So let's say I increase my E to be 4, then I will have this as 2. If I increase this to be 5, I have this as 3. So apa-apa yang lebih akan jadi KE max. Okay, so I hope that's okay. If you have any questions, boleh tanya. So F naught always at 0 KE max. When you increase the frequency, you are increasing the energy. When you increase the energy, there will be extras. Extras to become KE max. Okay. So the photon energy is used to overcome the work function of the electron and extra energy as the kinetic energy. So the minimum photon energy is equivalent to light with threshold frequency F naught. So we call this as the threshold frequency F naught. The maximum photoelectron kinetic energy K max is given by the same thing lah. So E equals to HF, this is the total, and it is equal to work function or HF naught plus K max. Okay, so HF naught ni is the work function or the binding energy, which is where KE max is 0. Apa-apa yang lebih daripada total energy akan menjadi K max. Okay. So different metals have different work functions ataupun different binding energies. For instance, copper has a greater work function than what is Na? Lupa. Is it sodium? Apa?
It's sodium.
Sodium, okay. And then aluminium lebih kurang dengan copper, zinc is lebih kurang. What is this? PT saya tak tahu apa. This is lead and this is iron. So all metals have different binding energy or work function. And this should be F naught, which is the threshold frequency. W equals to HF naught. This is the total E. Okay, any extras become maximum kinetic energy. Okay, so the maximum KE increases with increasing frequency. We talked about that. The maximum KE depends only on frequency and the work function of the metal, not on the intensity. Okay. We're not talking about intensity though. Okay, so abaikan. No electrons are emitted if the incident light frequency is below some threshold frequency. Okay, so we talked about F naught being the minimum frequency, or in this case, the minimum energy lah. Minimum frequency or energy. So dia nak cakap kat sini, no electrons will be emitted if your E is less than HF naught or not equal. Okay, or your binding energy lah, basically. Diulang-ulang je at this point, which is, I guess it's good lah untuk enforce. Okay, so example 22.4, blue light of wavelength 436 nanometer is directly incident to a metallic surface whose work function is 1.9 eV, 1.95 eV. Calculate the maximum kinetic energy of the emitted electron. So it's asking what is K max when W is equal to 1.95 eV. Okay, so we have our blue light of wavelength. This is our light. So from here we should be able to calculate what is E, right? Okay, And then it's asking what is the necessary potential to stop these electrons. So this is related to the equation of Ke max. Sekejap. Let's write down the equations that we need to use first. HF or apa? C equals to, tak ingat lah. This is HF, K max, HF naught. We have E equals to HF equals to K max plus HF naught or W. Saya nak equation yang untuk ni. E equals to something. Ni. This is the stopping potential punya equation. K max equals to EVS. K max equals to electron times the stopping potential. K max equals to EVS. So this is another equation. Oh, sorry, that is for B. K max equals to EVS. VS is stopping potential. And then there's another equation that we need to use, which is the equation that relates energy to wavelength, which I don't remember. E equals to HF. Mana? HC over lambda. So HC over lambda. Let's go back. So HF or HC. Kenapa tak boleh buat ni? What's wrong with my gendeknya benda ni. That's weird. Don't know what's going on. Dah lah sikit lagi nak habis pula tu. Geram betul. Kejap what do I do here? I want to save. Dan tutup. Okay. Okay, I got it. Okay, jangan stop share. Share balik screen. Okay, so we are back. I'm still recording. Okay, so HC over lambda. So this is the equations that you need to use. So blue light of wavelength 436 nanometer. From the wavelength, we should be able to calculate the total energy of the photons. So E equals to H is 6.626 times 10 to the minus 34, I think. C is 3 times 10 to the 8, I think. And then your lambda. So your 436 times 10 to the minus 9. So this should give you your E. Okay. And then it's telling you that the W is 1.9 EV, 1.95 EV. So your E, you should convert it to EV. Okay, convert your E to EV. So, nak kira ke? Malas ni. Kira jap. Let's just look at the jawapan. So you need to convert your energy to EV so that you can minus it with the W. Okay, so you will get your E from here or the HC over lambda. You know what your W is, it's 1.95 EV. You need to convert your E into EV as well so that you can just minus W, or you can convert your work function to joules to get your K max. Okay, let's see. So E equals to HC over lambda, 6.626 times 10 to the minus 34, 3 times 10 to the 8, 436 times 10 to the minus 9. So here, usually students make this mistake. They don't convert the nanometer lah, or the micrometer. So please do not forget this part. And then you will get 4.56 times 10 to the minus 19 joules. Divided by E, you will get your energy in EV. So you get 2.85 EV, and then we know that the equation is E equals to K max plus work function. Work function is 1.95 EV. E is 2.85 EV. Maksudnya kita ada lebih. Kalau tak ada lebih, K max equals to 0. So 2.85 minus 1.95 is equal to 0.9 EV. So that is your K max. This is your K max. Then K max is also equal to stopping potential times electron. Okay, so since your K max is already in EV, this is 0.9 EV. So your E cancels out. So EV ni refers to electron. It refers to electron lah. So when you have EV, when your when your energy is already in EV, when you divide it by E, the E cancels out. You are left with V. Okay. Again, I'm going to repeat myself. Kmax is joules. Kmax is energy. When we convert our energy to EV, okay, when we convert our energy to EV and then we divide with E, when we divide with the value of electron, the E cancels out, so we are left with voltage. Okay, so that is why Kmax is equal to EV. Okay, so E is electron value and V is the stopping potential. The necessary potential to stop these electrons. Okay, moving on. Molybdenum has a work function of 4.2 eV. So this is our work function or binding energy. Find the cutoff wavelength and the threshold frequency. This is F naught for the photoelectric effect to happen. Sekejap, I'm not sure if cutoff wavelength ni sama dengan threshold frequency. Sekejap sama. Cuma dia suruh tukar jadi wavelength je. Okay, so cutoff is basically threshold frequency but in wavelength form. So this is lambda naught. This is F naught. Okay, so they gave us the work function. So work function is equal to HF naught, right? This is the minimum energy that you have to overcome the binding energy or the work function. So H is just the Planck's constant, 24, and then F naught, I don't know what it is, 4.2 EV. Okay, so if I want to make this side of the equation in EV as well, I need to divide by electron value, which is, I don't remember, 1.602 times 10 to the minus 19. 1.602 times 10 to the minus 19. Okay, so now both sides are in EV. If I just use this equation, maksudnya kat sini saya tak divide dengan this part, this will be in joules. Okay, so tak boleh. You cannot have one side of the equation in joules and the other side in EV. You have to make them both the same. Either dua-dua jadi EV ataupun dua-dua jadi joules. So kalau nak pakai in joules, then you have to convert the EV into joules lah. Okay, so just use the constant and convert. Okay, so that is something you have to be aware of. So from here, from this equation, you should get the F naught. Okay, I don't know what it is. And then HC, sorry. Macam nak convert tadi tu lah. C equals to lambda, H lambda ke? C equals to H, tak ingat pula equation ni. Mana jawapan dia? Okay, this was the first equation that we learned, which I forgot. So C equals to lambda F. C equals to lambda F. Okay, so if my equation is F naught, then this guy will also be lambda naught. Okay, kalau this guy is at not F naught, then my lambda is also lambda yang biasa. Okay, but in this case, we are talking about the threshold frequency. which means that when I use the threshold frequency in this equation, I will get the cutoff wavelength. Okay, so here C equals to lambda F. Our F naught is, kalau ikut yang tadi tu, 4.2 EV convert jadi 6.626. Oh, dia tukar jadi joules. Oh, kat sini tukar jadi joules, dia tak pakai in EV. So 1.02 times 10 to the 15 hertz, and then yeah, I think this is pretty much straightforward. So you just convert the frequency, threshold frequency, to your lambda naught. Okay. So I think the hard part of this chapter is just memorizing a lot of equations and kena pakai interchangeably. So next one is calculate the stopping potential if the incident light has a wavelength of 180 nanometers. So we did this problem before, which was E equals to HC over lambda. So from here, we can know what is the E, and this is equal to W plus KE, sorry, K max. Don't use KE. And then from K max, you find out what is the stopping potential, like that. Okay, so pretty much straightforward if you know how to use the equation. So let's see the answer. So mana tadi? Okay, so dia kira E equals to HC over lambda for the wavelength. So they got 6.87 EV. Kmax is E, the total E, minus with the work function or the binding energy. So you get 2.67 and then 2.67 EV divided by E, you just get 2.67 voltage. Okay. Agak senang kalau dah pernah buat. Kalau tak pernah buat macam peninggal. Okay, so last one before we start with our presentation. When light of frequency 5 times 10 to the 14 hertz, so E equals to HF, this is the equation that you should use. Because dia tak pakai wavelength, dia pakai frequency. Is shown on a certain metal the maximum kinetic energy of the emitted photon. So it's telling you Kmax is equal to 2.31 times 10 to the minus 19 joules. What is the threshold frequency of the metal? So this is related to the work function, where work function is HF naught. Okay, so dia bagi kita E total, dia bagi kita K max, dia tanya kita what is F naught. Basically, it's asking you what is the work function lah. Okay, so E equals to HF 6.626 blah 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 times with the frequency. This is your frequency. This is your energy. And then from your energy minus dengan K max to get the work function. E tolak K max dapat work function. Work function is equal to HF naught. Okay, so basically it's just plugging in the numbers. So they used in joules here. 3.31 minus with, mana K max? Oh, this is the K max. Minus with 2.31 times with 10 to the minus 19, because dua-dua ada times 10 to the minus 19. So this is why dia orang buat dalam kurungan macam ni. Boleh je tak buat macam ni pun tak apa. So 3.31 times 10 to the minus 19 tolak 2.31 times 10 to the minus 19. Boleh. So E tolak K max akan dapat work function. Work function divided by H akan dapat F naught. Okay, H is just the Planck's constant. So frequency is in hertz. Do not forget units. Okay, I think this chapter banyak equation je. In terms of pemahaman, dia tak seteruk macam electromagnetic lah bagi saya. Electromagnetism is quite hard in my opinion. This one you just need to read and remember the equations. Okay, you should be okay. Soalan dia pun senang-senang. Tapi kena baca buku lah, jangan tak baca buku. Okay, so physicist. Tak nak jadi physicist pun tak apa, jadi engineer pun boleh. Okay. Ni menakutkan, orang-orang ni menakutkan. Okay, so let's start with your presentation. Any questions about chapter 22? We are done actually. So lepas ni, when your exam is on chapter 15, chapter 19 to 22. So 15, 19, 20, 21, 22. So 5 questions. 23 and 24, you will have to do what do you call it? Final assignment. It's not a final exam, it's final assignment. Assignment pada next week. Tak ingat hari apa, Khamis kot. So ada final assignment. And then 23 and 24 is also your presentation and your summary. Sebab 23 and 24 ni kenapa tak masuk exam? Because it's a lot. It's a lot for you to cover kalau nak masuk semua dalam final exam. That's why jadi assignment je. Sebab assignment kiranya macam laid back sikit lah. Okay, we are trying to help you here. Bukan nak saja nak susahkan. 23 and 24 memang kena cover. Tak boleh eliminate from the syllabus. So the way that we want to help you is make it into assignment and also into presentation. If not, it should appear in your final exam, which we don't want because it's a lot. Okay. So any questions about this chapter? Okay, good. I think you should just read and the equations.
Okay, Doktor.
Okay. So I'm going to proceed with presentation tau. So who is the first one? Tengok balik. Let's see. Sharing is pause. Tengok korang. Okay. Stop share. Okay, so hari ni Sofara dulu. Is Sofara ready? Sofara there?
Yes, Doctor.
Ready tak? Boleh present now?
Boleh.
Okay, kejap lepas Sofara, Anis cakap dia nak present juga. Is Anis there? Ke Anis nak postpone jadi Thursday?
Tak nak hari ni.
Hari ni juga, okay. And then Hikmah tak ada kan? Hikmah is travelling today or Hikmah nak present today? Hikmah tak ada, okay. Hai, jap. Kita kena ikut turutan modul sebenarnya. So the first subtopic is early model of the atom. Okay, sebenarnya Bohr's theory ni after early model of the atom. So let's start with Anis dululah. Anis dulu And then Hikmah. And then early model of atom, siapa lagi? Early model of the atom. Okay, lagi seorang, Danish. Okay, Danish, Anis dengan Hikmah. After that baru Sofara. Okay, stop sharing. You can start. Multiple participants can share. Okay, ready when you are.
Doktor, saya punya Niels Bohr. Proceed juga ke? Saya punya last kali.
Oh, awak punya yang first untuk chapter tu, untuk subtopik tu siapa?
Danish.
Okay, Danish dululah. Lepas Danish siapa nama dia? Hikmah kan? Tapi Hikmah ada ke? Hikmah tak ada. Danish, are you there?
Itu.
Boleh present sekarang? Okay. Tunggu Lepas Danish, Anis. Lepas tu Sofara. I don't see Hikmah here. Sebentar dia. Yang lain-lain tu get ready juga ya. And then lepas course sebab dia it's 1 to 2 minutes or more. So I'm expecting it to be fast. Hydrogen energy level, hydrogen atomic spectrum. Aisyah Fatimah Afikah. Okay. First model of the hydrogen. Okay. And then Oh,
Boleh start, Doktor?
boleh.
Okay, I will present for the early model of the atom, which is I will present about John Dalton and J.J. Thomson. And for the John Dalton, we state that he state that the atoms are indivisible, which means there are more molecules and atom, which is atom arranged in different combination to make a different compound. This is a model of sphere. Like that. And then for J.J. Thomson, we know that he discovered a continue of the John Dalton atoms and discover electron and won a Nobel Prize, which is he get he know about the model of pudding, plum pudding, which is the model of atom that show of electrons scattered throughout a spherical cloud of positive charge. He discovered electron and in the sphere is a plum pudding tu, this is the charge positif semua dekat spherical cloud tu. And then that's all from me.
Okay, thanks Danish. So apa yang kita boleh nampak kat sini is John Dalton dia cakap atom tak indivisible, maksudnya tak boleh pecah-pecahkan. Atom arrange dalam different combination to make compound. Lepas tu J.J. Thomson propose plum pudding punya model. Plum pudding dalam ni ada apa nama dia? Ada electrons dalam positive charge spherical cloud. Okay, thank you Danish. Next one Anis.
Assalamualaikum warahmatullahi wabarakatuh, and very good day I bid to Dr. Nadia Hussein and fellow friends. My name is Anis Nadira binti Nur Maisam. Sorry.
Kak, saya tumpang buang sampah
Okay.
dalam plastik hitam tu. Terima kasih.
Okay. Assalamualaikum warahmatullahi wabarakatuh, and very good day I bid to Dr. Nadia Hussein and fellow friends. My name is Anis Nadira binti Nur Maisam, ES 11512 from group 19. Today, I will present a topic on early model of the atom by Niels Bohr. All matters are made of an atom, and the ideas of what an atom is began at the 19th century. First model, which is the solid sphere model, was made by John Dalton in the year 1803, followed by the plum pudding model by J.J. Thomson in the year 1904. In 1911, Ernest Rutherford has come up with his model, which is the nuclear model. And the last one is Niels Bohr. In 1930, Niels Bohr had modified Rutherford's model of atom and proposed a new atom model by stating that first, electrons move around the nucleus in orbits of fixed sizes and energies. These orbits referred to as shells or energy levels. Next, electron energy in this model was quantized. An equation that calculates electron energy was found by Niels Bohr, which is delta E equal to HF equal to E initial minus E final, but it will be explained later by another presenter. Extra informations, maximum number of electrons that can be occupied by the inner shell is 2, while the maximum number of electrons that can be accumulated in the outer shell is 8. The orbit closest to the nucleus has the minimum energy, and the farthest orbit has the maximum energy. Electrons can be excited when atom absorbing energy and return back to the lower energy level by emitting energy. Moving on to the last point. The third point, electrons could not occupy values of energy between the fixed energy levels or orbits. Okay, which means these electrons must have at certain energies around the nucleus, and they can't be anywhere in between the orbits. To conclude, Bohr's model is easy to understand and works well for simple atoms. It is one among the atomic structure that's still in use today. 3 things to remember. First, electrons move around the nucleus in orbits of fixed sizes of n energies. Second, electron energy was quantized. And third, electron can't be anywhere between orbits. That's all from me. Thank you for listening. Good work, everyone, and thank you.
Thanks,
Okay.
Anis. That was good. Safe travel.
Okay, thank you, Doctor.
Okay, bye. Awak nak pergi terus kan? Okay, lepas Anis, Pak Anis, Sofara. Wah. Oh, by the way, nanti semua share presentation.
Assalamualaikum. I'm very
Oh, sorry. Okay, yes. Go continue, Sofara.
okay. Assalamualaikum. Very good afternoon to Dr. Nai and my fellow friend. So I will be presenting under the subtopic both theory of the hydrogen atoms. So in 1913, both provided an explanation of atomic spectra that includes some features of the currently accepted theory. So according to the double assumption, first one, proton, under the influence of the Coulomb force of attractions. And the Coulomb force is produced the electron centripetal accelerations, which is give us this equation, which is we know that F is equals to ma. So we need to substitute the centripetal accelerations formula in here. So the formula for the Coulomb force is F equals to mv squared over r and also equals to k squared over r. And then for the second assumption is both stated that only certain electrons orbit are stables and no energy is in the form of electromagnetic radiation is emitted, so that the total energy of the atom just remains constant. And then for the third one is when the radiation is emitted by the atoms, the electrons will jump from the higher energy levels to the lower energy levels. And then when the radiation is being absorbed by the atoms, so the electron will be jumped from the lower energy levels to the high energy levels. And the frequency of the radiations emitted or absorbed in the jump is related to the change in the atom's energy, which is giving us this equation, which is HF equals to EI minus EF, which is EI must be greater than EF. And these are the also is equation of the several energy based on the both models. We have here is a potential energy formula, which is P equals to negative K squared over R. And the kinetic energy, which is Ke equals to half m squared, also equals to half K squared over R. The total energy is E equals to Ke plus Pe, also equals to negative half K squared over R. And we also have here for the formula of the angular momentum, which is mvr equals to n times h over 2 pi. And also for the speed formula, we just need to make v as a subject from the angular momentum formula, which is v equals to n over mr times h over 2 pi. where the n, which is a quantum number, is equals to 1, 2, 3, and so on. And the next is the equals to h squared over 4 pi squared times mke squared, which times with the n squared, which is this one are the symbols as the a naught, which is just a constant. So the atomic radius formula is a naught times n squared. And the radii of the both orbits are quantized. And this shows that the electrons can only exist in a certain L orbit determined by the integer n. And when the n is equals to 1, the orbit has the smallest number radius of the A node, which is equals to 0.0529 nanometer. And the last one is the orbit energy. We have here is the formula of the energy of any orbit, which is En equals to negative half k squared over r. And this is also the another formula for the orbit energy. And if you want to find the orbit energy in joules, we can use this formula, which is negative 2.18 times 10 negative 8 times 1 over n2 joule. And if you want to find in electrovolt, we can use this formula, which is negative 13.6 times 1 over n2 eV. And these equations of the orbit energy is negative because when the electrons get closer to the neuron, they are losing some energy, which is due to the emissions of the radiations. And these are all the constants that will be used under this topic. So that's all for me. Thank you.
Thank you, Safara. That was really good. Okay,
Thank
next
you.
one is Afika.
Yes, Doctor.
Nak Afika dulu ke Aisyah dulu
I will present the questions and Aisha will present the theory.
Oh, Aisyah dulu lah then.
Okay.
Assalamualaikum and very good morning to Dr. Na and my fellow classmates. Today I'll be presenting on Bohr's theory of the hydrogen atom. So first is the Bohr's assumption. In Bohr's assumption, electron moves in circular orbits around a positive charged nucleus under the influence of the Coulomb force of attraction. This is because of the different charges of electron and proton. From the statement, given the equation, which is magnitude of Coulomb force equals to magnitude of the centripetal force, which is mv square over r equals to ke square over r, where m is the mass, v is the velocity, and r is the radius, and k is the Coulomb constant, e square is the electron charge, and r square is the radius. Bohr stated that only certain electron orbits are stable. These are the orbits in which the atom does not emit energy in the form of electromagnetic radiation, as electron moves at the same radius. The size of the allowed electron orbits is determined by a condition imposed on the electron's orbital angular momentum. So for if the electron jumps from higher to lower energy level, the radiation is emitted, and if the electron jumps from lower to higher energy levels, the radiation is absorbed. The frequency of the energy emitted or absorbed is related to the change in the energy of the electron as stated, HF equals to E initial minus E final. For the equations, the first equation is the potential energy, which is U equals to negative ke square over r. Second equation is kinetic energy, capital K equals to ke square over 2r. This equation is derived from the Coulomb force equation. The fifth equation is total energy, which is the sum of potential energy and kinetic energy, which is negative ke square over 2r. Then the angular momentum, mvr equals to n in bracket h over 2 pi, where h is then the seventh equation, which is mv square over r equals to ke square. Then mv square over r times mr equals to nh over 2 pi square in bracket square. And then the ball radius equation is Rn equals to h square over 4 pi square mke square of in bracket and n square. The radius of the ball orbits are quantized, which is n equals to 1, 2, 3, and so on. This shows that the electron can only exist in certain allowed orbits determined by the integer n. When n equals to 1, the orbit has the smallest radius called the ball radius, which is a naught equals to 0.0529 nanometer. Last one is the last equation is En equals to negative 1 over 2 ke square over r. The r is substituted from this equation, and at the end we'll get two types of equation, one in joule and one in eV. And the energy equals to 0 when electrons and neutron are separated completely. As electron gets closer to neutron, they loses energy, which is why the Bose equation, the energy calculated in Bose equation is negative. That's all from me. Thank you.
Okay, thanks Aisha. Next one is Afika.
Yes, Doctor. Can you see it, Doctor?
Boleh nampak.
All right. So, okay. Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon to Doctor and my fellow friends. So for today, I will present the question for the Bohr's theory of hydrogen atom subtopic. So this is all the formula that we need to remember, and we will use this formula in this subtopic. So this is all the formula that I already combined. And this is the constant that we will be used in this subtopic too. And I hope this will give in the exam. So I already checked the module and the web assign. So all of the module and web assign have the same type of question. So I will just use the question from the slide. But I will combine some questions from web assign too. So for the first question, an electron in a hydrogen atom is in the second orbit, which is n equal to 2. Using the Bohr's theory of the atom, calculate its radius, angular momentum, kinetic energy, potential energy, and total energy. So for the radius, we will just use the formula that have been given. And say that n is equal to 2, so we will include it in the equation. So we will get 2. Am I lag?
Apa dia Afika? Hello, saya ke yang putus-putus atau Afika yang putus-putus?
Sorry, someone just said, am I lag?
Saya tak tahu sebab internet
mine.
ataupun internet awak.
But I think it's mine.
Okay, tak apa, take your time. Kejap.
It's just okay.
Okay dah?
Yes, Doctor.
Macam dah okay dah? I think you can continue.
Okay. So I will start from this slide since the other slide is not very important. So I'll just start from this slide. Okay. So the question is about an electron in a hydrogen atom is in the second orbit, which is n equal to 2. Using the Paul's theory of the atom, calculate its radius, angular momentum, kinetic energy, potential energy, and total energy. So for the first question, we will just use for the radius, we will just use the formula that had been given. So we will take the n is equal to 2 and include in this n. So we will get the r is equal to 2.12 power of 10 power of negative 10 meter. So the radius for the angular formula that have been given, we include the n is equal to 2. So we will get the angular momentum, which is 2.11 times to 10 to the power of negative 34 joule second. So for the kinetic energy, we will have two equations, which is Ke is equal to half mv squared or equal to half Ke squared per r. But since we do not know what is v, so we will use this equation, which is half Ke squared per r. So we key in all the constant that already given and the r from the first question. So we will get Ke, which equal to 5.45 times to 10 to the power of negative 19 joule. So for the potential energy, we have the formula P is equal to negative Ke squared per r. So we will key in all the equation, key in all the constant and the r from the first question. So we will get the potential energy, which equal to negative 1.09 times to the 10 to the power negative 18 joule. I already checked all the answers and it's already correct. So for the last question, total energy. We have two equations, which is E is equal to negative half Ke squared per r, or we have E is equal to Ke plus Pe. We can use any of the equation because we already find the kinetic energy and potential energy. So in the slide, it just use negative half Ke squared per r, but I showed another equation so that we can compare that both of the equation will get the same answer. So for the next question, for the second question, it's just the same type of question, but it just use another n, which is n is equal to 3. So we need to find the radius, speed, kinetic energy, potential energy, and total energy. So for the first question, it's just like before. We will use the formula which it will be given. We put all the constant and the n is equal to 3. So we will get the answer is 4.76 times to the 10 power of negative 10 meter. So I have one question for all of you. In the web assignment, we need to key in the answer with nanometer. So what we need to do to get the, can I already know? Any of you can, oh no, it's unstable again.
Ada orang nak jawab ke?
0.476.
Apa? Tak dengar. Lagi sekali.
I
0.476 nanometer.
Afika dengar tak dia cakap apa? Afika? Afika hilang.
Um,
0.476 nanometer. Sob ni unit dia ke? Macam tak adalah. Afika, are you there? Afika hilang. Okay. Macam jawapan Amsha ni macam terbalik je.
oh no.
Afika, are you? Okay.
Yes, Doctor. Sorry, Doctor.
Okay. So Amsha jawab 0.476 nanometer. What's the actual answer?
Yeah, Doctor.
Okay.
Yep. It is 0.476 nanometer. Why am I internet problem right now?
Apa dia? Afika tak dengar.
Sorry, Doctor. So the answer is 0.476 nanometer.
Okay.
Wait. It's unstable. Wait.
Alright.
Okay. So for the next question, is unstable again. Oh my gosh. For the speed question. For the speed question, we do not have any equation that will give us the v, but we have the angular momentum equation that state the v in here. So we will use the angular momentum equation to get in all the constant and the n is equal to 3, we will get the speed is equal to 7.3 times to the power times to the 10 to the power of 5 ms per second, m per second. So for the next question, I'm sorry I cannot show it in the slideshow mode. Yeah, it's unstable again. So for the next question, the kinetic energy is the same again. Kinetic energy has two equations. So since we already find the V, so we can use this equation. So when we key in all the information, we will get the E is equal to 2.43 times to 10 to the power of negative 19 joule. So we already so in the website, we need to key in the answer. Ya Allah aku. Astagfirullahaladzim.
Okay, ada sesiapa nak jawab soalan Afrika? Afrika tanya, how do we convert 2.43 times 10 to minus 19 to EV? Ada yang baik hati nak mencuba?
I'm sorry, doctor, for the internet problem.
Yeah, no worries. It's not your fault. So Nadira said, Nut Mango said 1.52 EV. I don't know the answer.
So wait, I will just share the PowerPoint back.
Okay.
Yeah, the internet connection is problem right now. I don't know why. Maybe it's because it's raining today. Sorry, doctor.
Hey, don't worry about it. Tak apa. Biasalah tu.
So the answer is, yep, 1.52 EV. Yep,
Yay.
that's correct. So for the potential potential energy, we will use the negative K E squared per R, and we will get the potential energy is equal to negative 4.85 times to 10 to the power of 19 joule. And so for the total energy, E is equal to negative 1. E is equal to half Ke squared per R, or we can use Ke plus Pe, since we've already found the kinetic energy and potential energy. So when we compare both of the equation, we will get the answers the same. So for the last one, so this is equation from the web design. Can anyone calculate the linear momentum of electron? The n is the same. N is equal to 3. Can anyone calculate that? Do anyone know how to calculate the linear momentum?
Is it P equal to mv?
Let's see. Yep, it is P is equal to mv. So the m is a constant. The v we already found just now. Yep, we already found just now. So what's the answer, guys? Anyone know the answers? Come on. Is it Mario?
Umar jawab 6.65 times 10 to the minus 25.
Yep, that's the answer. 6.65 times to the 10 to the power negative 25. Yes, that's the answer.
Yay, okay.
Yeah, that's it from me. Thank you.
All right, thanks Afika. That was very good. Next one is siapa Kejap. Hydrogen energy level. Hydrogen energy level. Fatihah, Amshar dengan Haikal. Haikal is not here. I think Haikal is travelling today. So Amshar dengan Fatihah. Fatihah start dulu
Doktor, saya bentar ini kak.
Oh benar ni. Okay, sorry. Okay, Haikal go first.
Fatihah dulu.
Fatihah dulu, alright.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and good evening to Dr. Nat and my fellow friends. My name is Wanur Fatihah binti Warusli, and today I would like to give a short summary about one of the subtopic in chapter Atomic Physics, which is hydrogen energy levels. Okay, in Bohr model, it states that a photon is emitted when the electron drops from a larger energy orbit to a smaller energy orbit, when it is received energy that's greater than its orbital energy. And Bohr model also states that an electron can jump from higher to lower energy level and vice versa. That means that an electron also can jump from lower energy to the higher energy level. Electron in the ground state, which is n equal to 1, can be excited to higher state by absorbing internal energy. And the electron can absorb the internal energy by heating or collision. Electron in excited state may lose their energy by making transition to lower state by emission of radiation. The equation for the energy of emitted photon is given by delta E is equal to HF equal to E initial minus E final. And from this equation, we can derive it to get another equation, which is 13.6 bracket 1 over n final power of 2 minus 1 over n initial power of 2 bracket EV. So that's all from me. Thank you.
Okay, thanks Fatihah. Haikal, next. That was good.
Nampak ke slide?
Nampak tapi kecilkan sikit kot. Bawah dia saya tak nampak.
Oh,
Oh, memang macam tu ke rupa dia? Okay. Oh, memang nak
dia manjang.
dulu. Okay, okay. Alright.
Okay, so hello and Assalamualaikum warahmatullahi wabarakatuh to Dr. Nat and my fellow friends. So today I'm going to present hydrogen energy levels diagram. So every electron orbiting Bohr model is associated with a certain definite value of energy. Therefore, the energies of the orbit can be represented by an energy level diagram. Every horizontal line in the diagram corresponds to the energy of a particular electron orbit indicated by a quantum number n. As you can see in the poster, the horizontal line, the blue color, the blue line color. The hydrogen energy level diagram plots energy vertically and is useful in visualizing the energy states of a system and the transition between them. So the energy of each level or electron in any orbit is described by the following equation. E equals to negative 13.6 times 1 over n squared EV, electron volt. The value of energy are negative numbers, so the most negative value in fact correspond to the lowest energy. It is good to note that the lowest energy level an electron can have in an atom is called the ground state. In the ground state of the atom, the electron is placed in the lowest orbit with n equals to 1 and has an energy of negative 13.6 eV. The energy of an electron increases as it is excited to successive energy levels. While the energy increases, the energy levels become closer and closer together. As you can see in the poster, the top one is getting closer with each other. For the electron to get a higher energy level, we have to give the electron more energy. For radiation energy equals to the difference between the initial energy and final energy. The equation above will substitute to the radiation energy equation and we get 13.6 times 1 over n squared final state minus 1 over n squared initial state. So that's all from me. Thank you.
All right, thanks Haikal. Next is Amsha.
Hello. Jelas tak doktor?
Nampak? Okay.
Suara. Okay.
Suara pun okay.
Assalamualaikum and good day everyone. My name is Muhammad Amshad bin Hamid and my metric number is AS11682. Today we are discussing the exercises under the subtopic hydrogen energy levels. So let's go. Okay, so the first question. What is the energy of photon that when absorbed by hydrogen atom could cause the following? Kejap. Dah keluar jawapan. Kejap. Sorry doktor, kejap.
Tak apa. Amsyah ni orang Kelantan ke? Okey. Terus terkeluar kecil dia. So Amsyah punya last one for today. Nanti yang hydrogen atomic of spectrum dengan atomic spectra on Thursday and onwards. On Friday kita tak ada kelas. So Thursday tu kelas kita 2 jam ke atas. Sampai tak larat lah.
Saya teruskan je lah, saya malas edit. Sekejap lagi kita ada quiz. Okay. So A, an electronic transition from the N2 state to the N4 state. So to be observed, the energy of the photon must match the difference in the energy of the electron in the final and initial states. So to find the energy of the photon, we need to use the E radiation formula, where the N final is 4 and the N initial is 2, and we get 2.55 electron volt as the answer. The answer is actually negative, but it is mentioned that observed, so it only want the magnitude of the answer. And same for the question B, the initial is 7 and final is 7 and initial is 2, and the answer is 3.12 electron volt. And second question A, tak ada jawapan pula. Okay, so let's move on to exercise 2. This question is to calculate the energy difference resulted from the transition of an electron from N2 state to the N1 state. So we use the same previous formula to solve this question, where the N final is 1 and N initial is 2, and the answer is positive 10.2 electron volt, because the electron went from higher energy to lower energy states. Okay, now let's continue with our quiz. Okay, Kahoot
Okay guys, get ready. Amsyah nak kasih Kahoot quiz. Macam mana nak main? Host.
Kat kedua. Ya Allah, banyaknya juga.
Sabar.
Sorry. Okay.
Sekali kita try. Okay, boleh.
Okay.
Alhamdulillah.
Join dekat Kahoot app ataupun www.kahoot.it. Okay, saya pun nak main juga. Let's go everyone.
5 soalan je.
Okay, so masukkan nombor yang kat depan ni. Sekejap, internet saya pun slow. Okay, game pin 619-6455. Enter. Nama saya Nat. Tolong jangan hey. Siapa yang flower ni? Arlington.
Ramainya Amsyah.
Okay, mana yang lain ni? Lambat. Okay, baru ada 24. Mana yang lain? 25, 26. Kita ada 32 orang dalam Zoom ni. Orang lain mana? 26, we have 6 more people. Okay, 27. Okay, one more nanti kita start. 30 kita start lah. Internet orang tak stable. One more. Okay, tak ada orang. Tak ada dah.
Start kan? Start kan doktor?
Okay, start.
Lagu.
Yang siapa hot?
What is the lowest and most stable and one still called? Siapa jawab excited state ni? Aduh.
Siapa lagi seorang? Okay, final question.
Yay!
Congrats
Oh,
to
nasib
all the
baik
winners.
top 5. Okay, congrats everyone. Good job, Amsha. That was a good question. Okay,
That is all from me.
I'll see you guys on Thursday, alright? So prepare well for your presentation. All the best. Kalau ada soalan boleh tanya kat WhatsApp macam biasa. Take care, jaga SOP. Don't forget to have your dinner later. Okay, bye-bye guys.
Thank you, Doktor.
Bye.
Thank you, Doctor.
Thank you,
Thank you,
Doctor.
Doctor.
Thank you, Doktor.
Bye.
Thank you, Doctor.
Welcome.
Thank you, Doktor.
Welcome.
Thank you, Doctor.
Bye.
Thank you, Doktor.
Welcome. Bye.